Hi, in physics, pressure has a very specific meaning. You'll understand about pressure. Here's a hand. What I'm going to do is I'm going to use another hand and I'm going to push down on it. And if I push, you should know that that is a force. That's fine. Now we're going to swap over hands. And now I'm going to do the same thing. The difference is I'm going to lean on a pencil, which I've just sharpened. Are you ready? There's my, obviously I'm not really going to do it, but that should give you an understanding of the term pressure. Pressure. If a force acts on a surface, it is often useful to consider the pressure rather than the force. This is especially true when considering whether one material will move into another or make a hole in another. If we look at the pictures below, this one's got a sharp point, this has got a blunt, so you can imagine when you knock these in, the nail will penetrate the wood by applying a force with the hammer, and this nail is not sharp, so it's not likely to go into the wood. And that's what pressure is. Pressure is defined as your force per unit area. Pressure P is equal to force over area. So P equals F over A. Pressure is force over area. The units of pressure are newtons per square meter, because force is measured in newtons, area is measured in square meters. We're dividing it, so it's newtons per square meter, and 1 newton per square meter we also call 1 pascal. So the unit of pressure is the pascal. So this is from the National 5 notes. So as we've said here, when a force acts on a surface, it's important to think about the pressure, and if the force is spread over a large area, it's less likely to penetrate a surface than a force over the small area. So if you go back to the hands, when one hand was leaning on another, that was okay. But when the hand was leaning on a pencil that was got a sharp end, all that force is being pushed down into a tiny area, so the pressure in that area was very big, and I can assure you that hurt a lot. So here's some examples. NASA's Mars Curiosity had to have wide tyres. If you think over that, that's a large area. It's about the size of a small car, so that's the force, which in this case is the weight acting down, spread over a big area will give you a small pressure, and that will mean that the Mars rover won't sink into the sand. And again, off-piste snowboarders don't sink because the weight of the snowboarder, again the force acting downwards, is spread over the whole board. So it's spread over a large area, you don't sink into the snow. Different to that though is you've got nails, screws and needles. They've got a pointy end, so that any force applied to the end then goes through to a very, very small point. But because of that, you can think about, there was a dog recently that's just fallen into Lochmaben Loch. If you wanted to go and get your brother or sister because they'd fallen through the ice, you know, do you want to make yourself a very small area, or do you want to spread your weight over a large area? And I'm hoping that you think that you want to spread your weight over a large area, so it's not recommended, but if you have to go and rescue somebody, you need to make yourself as wide as possible. So lie on your stomach, put your hands and legs out, and then that will reduce the pressure over the surface and less likely to crack the ice. But better still, don't go anywhere near ice because it's dangerous. Pressure is defined as the force per unit area. Pressure is force over area. P equals F over A. The units are pascals, and 1 pascal is 1 newton per square meter. So we've got a snowboard of mass 70 kilograms rides on a snowboard which has a mass of 10 kilograms. The area of the snowboard in contact with the snow is 0.4 square meters. Calculate the downwards pressure. Now it's very tempting to say mass is 70 plus the mass of my skateboard is 80, so 80 over 0.4. But remember that your mass is not the same as your weight, it's not the same as your force. The force acting on the snow is the weight of the snowboarder and the snowboard. Now I think you'll find that here we take G as 10, which you know it's 9.8 newtons per kilogram. First, find the downwards force, so that's the weight of the snowboarder and the snowboard, so you can add the masses together. So that's 70 kilograms plus 10 kilograms times by 10, or if we're doing it properly at National 5 level, we times that by 9.8 newtons per kilogram, gives you 800 newtons or thereabouts. Force over area gives you your pressure. Your force is 800 divided by your area, 0.4, which gives you 2,000 pascals or 2,000 newtons per square metre. So have a go at some of the questions I've given you. Thank you very much. Well done.